Here is the solution guide for the worksheet about predicting chemical reactions. You can see that there's a step 1, step 2, and step 3, and we'll do the questions in that order. Question number 1 has already been done as an example. On the separate worksheet that you then have to copy onto this answer blank, you'll notice the chemical reaction filled in where it says steps 2 and 3. Actually, we're only given the left side of the reaction, the reactants. And we're asked, what format does that fit? Because the left side of this equation has an element plus another element, that format is combination. And I've written that where it says step 1. Then I followed the combination format to write down what the product would be. If you have the element calcium and you add the element oxygen, that's going to create a single compound as the product called calcium oxide, which I've written CaO, including the solid in the parentheses. And then after doing step 2, where you write out that skeleton equation, do step 3, balance the equation. That's when I finally filled in that I need 2 calciums, and over here, 2 calcium oxides. Here comes number 2. I've written down the reactant side from the separate worksheet. We're starting with one reactant, K2CO3 solid, potassium carbonate. When you start with one reactant, the reaction has the format of decomposition. That gets written in the answer blank where it says step 1. In step 2, follow the decomposition pattern and write down the products of the decomposition. It's going to separate into the components that make potassium carbonate. When we were doing worksheet number 2, the one about decomposition, we discovered that if you have a metal carbonate and it decomposes due to being heated or having electricity run through it, it produces a metal oxide and carbon dioxide gas. So our metal oxide is potassium oxide. Potassium is positive 1. Oxide is negative 2 with crisscross method K2O1. Potassium oxide is solid. The other substance produced is carbon dioxide gas. In order to know those are the products, I have to pay attention to the previous worksheet that I did about decomposition. Hopefully you saved those worksheets in your notebook. Now comes step 3, balance this skeleton equation. It's already balanced. There is 2 K's here and 2 K's here. There's 1 C here and 1 C here. There's 3 O's here, and adding together this O and these 2 O's, that's 3 O's. Next, question number 3. I've copied down the given information from the worksheet. Then, pay attention to this format. We have 2 aqueous ionic compounds being mixed together. This format is double replacement. Once you've identified the format, then you can follow the pattern of that format to create the products. In double replacement, the cations switch positions. The copper and the sodium switch positions. So the Na will be bonded with the NO3, sodium nitrate. Sodium is positive 1, nitrate is negative 1, no crisscross needed. Sodium nitrate might be aqueous or solid. We're going to discover that by looking at the solubility chart. The other product is copper sulfide. The copper is positive 2, and the sulfide is negative 2. These are opposite charges, no crisscross needed. Again, that product will be either aqueous or solid. We'll discover that by using the solubility chart. Look up the solubility of sodium nitrate. That can be done in one of 2 ways. You can look up nitrate, that's the first row of this chart, and read what it says. All nitrates are soluble. So sodium nitrate is soluble. It's aqueous. The other thing you could look up is in the very bottom row. It's kind of covered up by this icon here, but it says sodium under there. And so it says all salts containing sodium ions are soluble. So once again, that means it's aqueous. Now let's look up copper sulfide on the solubility chart. Find sulfide. Here it is. Second to the last row. It says all sulfides are insoluble except a few of them, but I don't see copper as an exception. So copper sulfide is insoluble. That means it's solid. For a double replacement reaction to occur, one of the products must be a solid, liquid, or gas. One of our products is a solid, so this reaction does occur. Step 3, balance this equation. On the left side, there's 2 nitrates, so we need 2 nitrates on the right side of the arrow. We can put a 2 right here. In turn, that makes 2 sodiums. On the left side, there is 2 sodiums. On the left side of the arrow, there's 1 Cu, and on the right side, 1 Cu. There's 1 S on the left, and there's 1 S on the right. The equation is balanced by inserting a single 2 in front of the sodium nitrate. Question 4. I've copied down the reactants. Now inspect the reactants. Pay attention to the format. Aluminum is an element. Tin chloride is a compound. This has the format of single replacement. However, it is the single replacement reaction that you have to look at the activity series to see if the reaction actually occurs. We have to find out if aluminum is more reactive than tin. On this chart, find aluminum and find tin. And tin is underneath, so aluminum is more reactive than tin. That means that the aluminum will replace the tin in its bond to the chloride. The tin will become the lone element. It'll be solid. Tin is a metal. And the aluminum is going to bond with the chloride. Aluminum, chloride. Aluminum is +3 and chloride is -1. So crisscrossing, Al1, Cl3. Aluminum chloride is a solid. Step 3, balance this equation. There's 2 Cl's on the left and there's 3 Cl's on the right. So if we make them both into 6 Cl's, it'll be balanced. Put a 3 here, put a 2 here. This makes 3 tins, so we can put a 3 here. And this makes 2 aluminums, so put a 2 here. Question 5, I've written down the reactants from the worksheet. Now look at the format. This is an aqueous ionic compound being combined with another aqueous ionic compound. This format is called double replacement. In double replacement, you exchange the cations. The first item from here exchanged with the first item from here. The lithium bonds with the chloride. Lithium chloride. Lithium's +1, chloride's -1, no crisscross needed. Then say aqueous or solid, whichever it is when you look up on the solubility chart. The other compound that's created will be the magnesium paired with the carbonate. Magnesium is +2, carbonate is -2, a little bit of scrap work there. And notice there's no crisscross needed. And then the parentheses to write aqueous or solid. First, look up lithium chloride on the solubility chart. Chlorides are the third row down. All chlorides are soluble except for, but it doesn't have lithium there, so chlorides are soluble. They're aqueous. Next, look up magnesium carbonate. Looks like the fifth row down has the carbonates. All carbonates are insoluble except for, so it's saying our carbonate is insoluble. It's a solid. As long as one of the products of the reaction is a solid, liquid, or gas, then the reaction does occur. Now we need to balance this. On the left side of the equation, I observe 2 chlorines. So on the right side, put a 2 here, that'll make 2 chlorines. It also makes 2 lithiums, and on the left side, there's 2 lithiums. There's 1 magnesium on the left. There's also a carbonate on the left. And on the right side, there is a magnesium and there is a carbonate. It's balanced by filling in that 2. Number 6, on the left side of the arrow, there is a single compound. The compound is called iron 3 nitrate. And there's this dot and then there's 9 H2Os. What that indicates about the iron 3 nitrate is that it's hydrated. Each formula unit of iron 3 nitrate is surrounded by 9 water molecules that have an attraction to the unit of iron nitrate. This substance is solid, so even though it has all these water molecules within the crystal structure, it's still solid because the water molecules are very strongly locked into position. They're not able to flow around like they do with a liquid. There's only one compound on the left of the arrow, so this format is called decomposition. That one compound can break apart into 2 things added together. A couple days ago, we had a worksheet with decomposition questions, but I don't remember there being a hydrate on that worksheet. When a hydrated compound is decomposed, that simply means that the water molecules separate from the ionic compound portion. So this is going to make iron nitrate and it's going to make the water molecules. The water will be a liquid. The iron nitrate will either be solid if it doesn't dissolve in the liquid water that has just been produced, or it will be aqueous if iron nitrate is dissolvable in liquid water. If you look at your solubility chart, nitrates is the very first row. It says all nitrates are soluble. So the iron nitrate dissolves in water. It's aqueous. Step 3, balance the equation. It's really straightforward. We just need to get that 9 in front of that water. Question 7. I've written out the problem. Now let's pay attention to what we have here. We have an aqueous ionic compound being combined with another aqueous ionic compound. That was double replacement. Switch the cations. The Pb joins with the S, lead sulfide. Now let's pay attention to charges. The charge of the lead is positive 2. Because in this compound right here, there were 2 nitrates that paired with the lead. Nitrate is -1, so if you have 2 nitrates, that's -2. Therefore, the lead had to have been positive 2 to balance with the nitrates. Sulfide is -2 because it's in group 6A. These are opposite charges, no crisscross needed. The formula for lead sulfide is just PbS. I'm going to put parentheses, and we'll fill them in later with solid or aqueous. The other product created starts with ammonium. And that ammonium is bonded to nitrate. Ammonium is +1 on your ions chart. Nitrate is -1. These are opposites, no crisscrossing needed. And the parentheses. Let's look up lead sulfide on the solubility table. Sulfide is the second from the bottom row. All sulfides are insoluble except for, it does not list lead as an exception. So our sulfide is insoluble. It's a solid. The other one, ammonium nitrate. Remember the first row of the solubility table. All nitrates are soluble. So our ammonium nitrate is aqueous. Because one of the products is a solid, this reaction does happen. Now we need to balance it. On the left side, there's 2 ammoniums. And on the right side, if we put a 2 here, that makes 2 of the NH4s. It also makes 2 of the NO3s. And on the left side, we have our 2 NO3s. There's 1 PB and 1 PB. There's 1 S and there's 1 S. This is balanced by filling in that single 2. Question 8. Here are the reactants written down. Let's look at the format. Copper is an element. Iron nitrate is a compound. An element combined with a compound has the potential to be single replacement. But only if the lone element is more reactive than the element that's in the compound. We have to look at the activity series. We want to know, is copper higher than iron? Here's iron about right in the middle of this chart. And here's copper closer to the bottom. Copper is not higher on the chart than iron. The copper cannot replace the iron in its attractions to the nitrate. This is no reaction. So we were thinking it's single replacement. We can go back and erase that in step 1. It's not actually single replacement. There's no reaction. No products are created. Okay, number 9. Pay attention to the format. Potassium hydroxide is an aqueous ionic solution. Hydrogen sulfate is an aqueous ionic solution. This is double replacement. Switch the positions of the cations, the potassium and the hydrogen. We're going to put the hydrogen with the OH. In your mind, when you put a hydrogen with an OH, it makes HOH. HOH is just another way of writing H2O. It's water. I know that's liquid. I can fill it in right now. The other compound created has the K, and the K goes with the sulfate. Now let's see, do we do any crisscrossing? K is +1 because it's in group 1. Sulfate is -2. We need to crisscross a 1 and a 2. So we have a 2 with a K, and then only 1 of the SO4s. We're going to look up potassium sulfate on the solubility table. Sulfate's like right in the middle of the table. All sulfates are soluble except for, I don't see potassium mentioned as an exception, so our sulfate is soluble. It's aqueous. Because one of the products was a solid, liquid, or gas, right? Right here we have some liquid made, then this reaction does occur. Now we need to balance it. There's 2 Ks on the right, so if we put a 2 right here, that makes our 2 Ks. This also makes 2 Os, separate from the Os that are kind of part of the sulfate ion. So for this to be 2 Os, we could put a 2 in front. That makes 4 H's in this spot. On the other side of the arrow, here's 2 H's, and here's another 2 H's. So there's 4 H's. This equation is balanced by putting in a couple of 2's. Number 10, I've written down the reactants. We have an element and a compound. This has the format of single replacement. For single replacement to happen, this element has to be higher on the chart than the cation that's in that compound. Mg has to be higher than hydrogen on the activity series. Magnesium is up here. It's the first one in the yellow section. Hydrogen is further down below, so magnesium is higher than hydrogen. The reaction is going to happen. Hydrogen becomes the lone element. That's hydrogen gas. And the magnesium joins with the chlorine. I want to write the formula of magnesium chloride. Magnesium's positive 2, this one's negative 1, and so we need a 2 right there. Magnesium chloride is kind of a white solid substance. Now balance. There's 2 H's on the right side, so put a 2 right here. That 2 also makes 2 chlorines, and there's 2 chlorines, so it's balanced. Number 11, look at the format. You've got a couple of aqueous ionic solutions being combined together. Double replacement. Switch the cations. So the sodium goes with the nitrate. Sodium's positive 1, nitrate's negative 1, no crisscross. Take the silver and put it with the sulfate. Silver's positive 1, sulfate's negative 2. Crisscross the 1 and the 2. 2 silvers, but only 1 sulfate. Do you remember what the solubility chart said about nitrates? They're always soluble. This one's AQ. Let's look up silver sulfate. Sulfate is the 4th row down. All sulfates are soluble except for, I don't see silver mentioned as an exception, so our silver sulfate is soluble. That means it's aqueous. For a double replacement reaction to happen, one of the products has to be a solid, liquid, or gas. That did not happen here. We're told to cross out our suspected products, cross out double replacement, and write down no reaction. Number 12, look at the format. An element, a compound, single replacement. But single replacement doesn't always happen just because you have an element and a compound coming together. The tin has to be higher than the lead on the chart. Tin is right above the lead, so tin is a tiny bit higher than the lead. Lead becomes the lone element. Lead's a metal, it's going to be solid. And the tin is going to bond with the nitrate. Looking on the ions chart, tin is +2, nitrate's -1. So we need to have 2 nitrates to go with that tin. Tin nitrate is a solid. The next step is to balance this. As I look at this, I have the same amount of SNs, the same amount of PBs, and the same amount of nitrates on both sides of the arrow. Number 13, the same pattern as we just had, an element and a compound. Do you notice how 13 fits the same pattern as number 12? Single replacement. But only if sodium is higher than hydrogen. Sodium is way at the top of this chart. Hydrogen's further to the bottom. So sodium is definitely more reactive than hydrogen. The hydrogen becomes the lone element, hydrogen gas, and the sodium bonds with OH. It's called sodium hydroxide. Sodium's +1, OH is -1, no crisscrossing. Sodium hydroxide is solid. I've got some in the supply room. It's these little solid pellet things. Next step is to balance this. The left side of the equation has 2 hydrogens. The right side of the equation has 3 hydrogens, but those hydrogens are in 2 different places being added together. To balance this, I'm going to put a 2 right here. That makes 2 NAs, so a 2 here. When I put the 2 right there, that made 2 O's on the right. So a 2 right here makes 2 O's. 2 times 2 is 4 H's, and on the right side there are 4 H's. Number 14, there is a single compound on the left side of the arrow. The only thing that can happen is that can decompose. Copper nitrate is a metal nitrate. A couple days ago on the decomposition worksheet, we looked at metal nitrates. Metal nitrates decompose into a metal nitrite and oxygen gas. So here comes the metal nitrite, CuNO2. Let's see if we have any crisscrossing. Our copper is +2, and nitrite is -1. So we do need to crisscross the 2 with the 1. We need 2 of these nitrites. This is going to be a solid. The other product is O2 gas. For you to know that, you have to have participated in the decomposition worksheet a few days ago and save that worksheet in your notebook so that you can look at it. Next, balance. There's the same amount of coppers on both sides. Right now, there's the same amount of N's on both sides. There's 2 N's on both sides. Are there the same amount of O's? 3 times 2 is 6 O's. On the right side, 2 times 2 is 4 O's. And here's another 2 O's. That's also 6 O's. This equation is already balanced. Number 15, adding together 2 elements. Aluminum is an element, and oxygen is an element. This is combination. A metal and oxygen combine to make a metal oxide. Aluminum oxide. Think about crisscrossing. Aluminum's +3, this is -2. You definitely need to crisscross. Next up, balance. There's 2 oxygens on the left and there's 3 on the right, so if we make them both be 6, that will balance them. A 3 here, a 2 here. Now look at aluminum. 2 times 2 is 4, so a 4 here. Number 16. We've had this earlier. There's a single compound on the left side of the arrow. And that compound is the hydrated version of barium chloride. The only possible reaction you can have when you have a single compound on the left side is decomposition. And decomposition of a hydrated compound is really easy to do. The barium chloride simply separates from the liquid water. Now, is the barium chloride a solid that settles out of that water, or is the barium chloride going to dissolve into that liquid water, in which case we will say aqueous? So let's look at our solubility table. Chloride is the third row down. All chlorides are soluble, except for, but it doesn't list barium as an exception, so it's soluble, it's aqueous. This is balanced, and just getting that 2 in front of that water. Number 17, an element plus a compound. Single replacement. Single replacement happens if the element is more reactive than the compound. Is lead higher than aluminum? Aluminum is the second one from the top in the yellow section. Lead is the bottom one in the yellow section. So lead is not higher than aluminum. The lead can't replace the aluminum in its attraction to the nitrate. No reaction's going to happen. I was thinking it was single replacement, but it's not. So I'm going to cross that out. Number 18, there's an element and there's an element. The only possible reaction type that this can be is combination. These two elements can combine together. Because these are both nonmetals, there's not some easy, obvious way for us to know the formula of the substance that's created. For this one question, I'm going to Google search what is created when S8 mixes with O2. The internet never lies, right? If this person is correct, it's SO2, sulfur dioxide. Then balance this. There's 8 sulfurs on the left side, so putting an 8 right here makes 8 sulfurs. 8 times 2 is 16 oxygens, so putting an 8 right here will make the 16 oxygens. Number 19, a couple of aqueous ionic compounds. Double replacement. Switch the cations. So the sodium goes with the phosphate. Sodium's positive 1, this one's negative 3, so you need a 3 after that Na. It's either aqueous or solid. Okay, the other one, take the hydrogen and put it with the OH. But we can do better than this. HOH, that's just the same thing as H2O. H2O is liquid, unless it's really cold or it's really hot. We need to look up sodium phosphate and see what the solubility chart says about it. 2 ways to look it up. You could look up phosphate, or in the very bottom row, it's kind of covered up again by this little icon thing, but it says sodium right there. All salts containing sodium are soluble. So this one's soluble. It's aqueous. A double replacement reaction occurs if one of the products is solid, liquid, or gas, and we do have a liquid. Now let's balance this. There's 3 NAs on the right, so we can put a 3 right here to get our 3 NAs. Right now, there's the same amount of phosphates on both sides. Let's check out our O's and our H's. And when I say O's, I mean the O's that aren't part of the PO4. So there's 3 O's right here. And so on the right side, we can put a 3 here to get 3 O's. 3 times 2 is 6 hydrogens. On the left side, there are 6 H's. There's 3 of them here, and there's 3 of them here. Number 20. This is our first one on the worksheet. That's going to be combustion. This is a hydrocarbon. And it's being reacted with oxygen. This is combustion. Our notes about combustion reactions show that the products are carbon dioxide and water. Now you could say that the water's liquid, or you can say that the water's gas. Because combustion reactions create a lot of heat, better to say that that water is in vapor form, that it's steam. Now balance the equation. For combustion reactions, balance in alphabetical order. The C's first. We need a 3 right here. Then the H's. Because there's 8 H's on the left, we put a 4 right here. 4 times 2 is 8. Finally, the O's. Count how many O's are on the right side, and then make the left side have that many. So 3 times 2 is 6. And then here's another 4. There's 10 O's on the right, so we can put a 5 in this spot to make 10 O's. Number 21. You recognize that format yet? Double replacement. Switch the cations. Na is going to go with the chloride, NaCl. That's either solid or aqueous. You might already know without looking anything up that sodium chloride does dissolve in water. It's aqueous. The other one is the barium paired with the nitrate. Barium is positive 2. This one's negative 1. So we need to have 2 nitrates. Do you need to look it up? Do you remember what the chart said about all nitrates? They're soluble. They're aqueous. Both products are aqueous. This means that they are not actually new products. It's not double replacement. There's no reaction. We started with 4 separate ions, all dissolved in water. We mixed them all up, and we still had 4 separate ions, all dissolved in water. The very last one. What's the format of this? You've got the element hydrogen being combined with the element bromine. Combination. It's going to make hydrogen bromide. Think hydrogen bromide is a gas under normal conditions of temperature and pressure. I'm not certain on that. I could look that up on Google and find out. I'm going to put gas though. Now balance it. There's 2 bromines on the left, so put a 2 right there, and that also makes the 2 H's that we need. This concludes the answer video on the worksheet.